All right, so you've got the basics of SQL down, but have you ever felt like you've just hit a wall? Like your skills have plateaued? Well, you are in exactly the right place. Today, we're going to blow past those basic select statements. We're going to equip you with an advanced toolkit that will help you really, truly master your MySQL database. Let's get right into it.
So let me ask you something. Does this scenario sound familiar? Your application, your database, it's getting bigger, right? And your queries, they're starting to look like a tangled mess of spaghetti code. You find yourself writing the same complex joins again and again. Or maybe you're getting a little nervous about who has access to what data. It's a super common problem, a growing pain every developer feels at some point.
But what if I told you there's a specialized set of tools already built right into your database designed to fix these exact problems? Think of it like a database architect's toolkit. And today, we're going to open it up and pull out 3 incredibly powerful tools: temporary tables, views, and stored procedures. Let's grab that first one.
Okay, tool number 1. This is your personal temporary workspace. It's all about handling those messy, complex jobs without leaving a permanent mark on your database. Seriously, just think of it as a scratch pad for your data. So what is a temporary table? It really boils down to 2 key ideas. First, it's private. Only you can see it. Second, it only exists for your current session. What does that mean? It means the second you disconnect from the database, poof, it vanishes. It's gone, leaving 0 clutter behind in your main database. Pretty cool, right?
So, when would you actually use this thing? Well, imagine you're building a big report, a report that takes like 3 or 4 really complex steps to generate. Instead of writing a nightmare of nested subqueries, you can just store the result of each step in its own temporary table. It's perfect for isolating data for a specific task, cleaning it up before you use it, or for those really tricky update with join situations. It just keeps your logic clean, simple, and easy to follow.
And honestly, the biggest win here is safety. It's a huge deal. Because no one else can even see your temporary table, let alone touch it. It's like your own private sandbox. You can go wild, manipulate data, run crazy calculations, test things out, and you never have to worry about messing up production data or interfering with what other people are doing.
Okay, let's put the scratch pad away and grab the second tool from our kit. This one is all about security and simplicity. It's the tool you reach for when you need to hide complexity and get really granular about who sees what. And that tool is called a view. Now, the most important word to remember here is virtual. A view looks like a table, you can query it like a table, but it's not a real table. It doesn't actually store any data itself. Think of it more like a saved query, a lens that you look through. Every time you access it, it runs the query and gives you a live, up-to-the-second window into the real tables underneath.
And this is exactly why views are so incredibly useful. Let's talk security first. You can create a view that only shows, say, employee names and departments, but hides the salary column. Boom, instant data protection. And what about simplicity? You know that monster 5-table join that everyone on your team has to write all the time? You can just save it as a view. Then everyone can just run a simple select star from your view. The complexity is hidden, and you guarantee everyone is using the exact same logic every single time.
Okay, but here's the question I get all the time. Can you actually change data through a view, like run an update or an insert? The answer is, it depends. A view is only updatable if it's incredibly simple. And by simple, I mean it has to point to just one table, and it can't have any fancy stuff like group by clauses or aggregate functions like sum function. Why? Well, think about it. MySQL has to know exactly which single row in the original table to change. As soon as you add joins or group things together, that one-to-one connection gets blurry, and MySQL just says, nope, this is read-only now.
All right, time for our final tool, and I gotta say, we've saved the most powerful one for last. This is what I like to call the reusable logic box. This is how you package up entire workflows and make your database smarter, faster, and more secure.
Let me introduce you to the stored procedure. Now, don't get this confused with a view. A view is just a single query. A procedure? Oh, that's a whole different beast. It's a full-blown script. We're talking multiple commands, variables, if-then logic, the whole shebang, and it's all stored and precompiled right there on the database server. All you have to do is execute that entire block of logic with one simple call command. So how do you talk to these procedures? You use parameters. It's pretty straightforward. You have in parameters to pass data into the procedure, like a customer ID. You have out parameters to get data back from it, like a final sales total. And then you have in-out, which is a two-way street. You pass a value in, the procedure can change it, and then it passes the new value back out. And hey, quick pro tip for you. When you're actually writing one of these, you'll have to use the delimiter command. It's just a little trick to tell MySQL, hey, my procedure code isn't finished yet, even though you see a semicolon.
Now, probably the biggest advantage of storing all this logic on the server is performance. I mean, think about it. The procedure is already compiled and waiting. So instead of your app sending a huge, long script across the network every single time it needs to run, it just sends one tiny little call statement. For tasks you do over and over again, that reduction in network traffic can give you a huge performance boost.
Okay, here's another thing that trips people up all the time. What happens when you need to change the code inside a procedure? You might think you can just alter it, right? Nope, you can't directly edit the logic. The process is always two steps. First, you have to drop the procedure, which means you completely delete it. Then you create the new version with your updated logic. It's always drop and recreate.
And I know what you're thinking, but I've seen an alter procedure command. You're right. It exists, but it doesn't do what you think it does. It's not for changing the code. That command is only for changing the metadata about the procedure. Things like its comments or, importantly, its security settings, which we're about to talk about.
And this is a really critical security concept, so listen up. A procedure can run in one of two security modes. The first is definer. This means the procedure runs with the permissions of whoever created it, which is usually a high-level admin. This is perfect for when you want to let a junior user perform a very specific, safe task that normally they wouldn't have the permissions for. The other mode is INVOKER. This one runs with the permissions of whoever is calling it right now. This is the safer default because it guarantees that no one can use the procedure to do something they aren't already allowed to do.
So let's pull it all together and look at our complete toolkit. We've got 3 essential tools. First, the temporary table. That's your private workspace for safely crunching intermediate data. Second, the view. That's your secure virtual window for simplifying complex queries and locking down access. And third, the stored procedure. Your reusable logic box for cranking up performance and keeping all your business logic in one place.
Honestly, by mastering just these 3 things, you can start building databases that are way more efficient, way more secure, and a whole lot easier to maintain. So I'll leave you with this question. You've got the tools in your hands now. What are you going to build with them first?